Okay. All right. So, all right, this time it's actually going to work, the sound, I hope. So here we go. Okay, so this is the quiz review. So on Thursday, you should expect to get a question like this, and you're gonna do it, and then you're gonna video yourself explaining it to me in a very short little video. Okay, so we will see the details on that on Thursday. I'll post that. So expect that will be Thursday's tasks. Okay. All right, so the first thing that you're going to do is balance the equation. So I've already kind of pre-filled out this key on here. All right, but the first thing you're going to do is balance the equation in whatever way you need to balance it. All right, so it's going to look like this. The balancing should be relatively simple because I'll try to keep it to the easier ones because of everything that's going on, okay? All right, so this will be a 1, 2, 1, 2. And then you're also going to see this now in the equation, this delta H term, which is going to tell you how much energy either leaves the system or comes into the system, okay? In this case, when that energy is negative, that indicates that it's exothermic because the delta H is negative. That means that some energy came in, but more came out, which is why it's negative, all right? If this delta H shows positive, that's going to mean that the reaction was endothermic. More energy went in than out. All right. Okay. You're also going to have to name the type of reaction. So this one's a combustion reaction because it has some kind of a hydrocarbon combining with oxygen. That's the burning aspect. And that always is going to make carbon dioxide and water. All right. So you need to make sure you can classify the reaction. It might be single, double replacement, decomposition, or synthesis. Okay. All right. So make sure you can do that. Then you're going to draw the particle diagram for me. I'm kind of a fan of using these Google drawings. They come out really clean and nice. But if you want to hand draw it, you can do that as well. All right, so you're going to have, here's your methane. So you have a carbon with 4 hydrogens, okay, combining with 2 diatomic oxygen molecules. So be careful because some of you are still kind of sloppy with this. I need to clearly see the 2 oxygens are connected and separated from the other mole of the oxygen, okay? So just watch your drawings carefully, all right? That's going to make 1 carbon dioxide, 2 waters, okay? And don't forget to add in where the energy is. So remember, if it's exothermic, the energy is going to be like a product. It's coming out. If it's endothermic, you would put it over here with the reactants, all right? Okay, then you're going to do the word equation. Make sure that you actually name everything in the word equation. Some of you are still putting formulas down here, okay? This is the formulas. This is the words, all right? So you need to go back and think about the naming. You might have to go back and practice that. From Unit 6, there's some help videos in there. I think it was Unit 6. No, I don't know, whichever one will rename the things. Okay, so I'm going to make sure in the word equation, I'm going to have the amount. So I'm going to say 1 mole of methane gas. Okay, CH4 is methane. That's a common one. You should probably just start knowing. But if you notice, I wrote it down here for you. Okay, so always if you don't know the name, look around because I might have written it somewhere. Okay, and I want you to include the state of matter if it's included in the equation. Okay, so 1 mole of methane gas combines with 2 moles of oxygen gas. Okay, to form. That's like, don't say equal, say something like to form, to create, to produce, something like that. 1 mole of carbon dioxide, okay, and in the key I forgot to write gas. I'll go add that in. 2 moles of liquid water, okay, because there's an L right here. Okay, and energy. Don't forget the energy term. That's important. Okay, so that's your word equation. Then we're going to do the math part from, this was like practice 3, I think. According to this equation, 1 mole of methane will release, because it is exothermic, so I'm releasing energy, 890 kilojoules of energy. Okay, so I'm getting that from up here, right? Remember, one of these, oh, wow, that was cool. Did you see that? Okay, is going to make one of these. Okay, so one of these is going to make whatever it says here, which is negative 890 kilojoules of energy. All right, so you're just going to read that recipe off. All right, so in my dimensional analysis, if I'm starting with 3 moles of CH4, here's the ratio that I'm setting up from here. Okay, negative 890 kilojoules over 1 mole of CH4, so those will cancel. Okay, and that's going to give me negative 2670 kilojoules of energy. Okay, and that is going to be released because it is exothermic. Okay, release is an exo word. Okay, all right. Now, this part is the part I think is going to be kind of confusing. So this is what I said in the update. I should have made all these kilojoules. So if yours still says joules, for all of these, it should be kilojoules. Okay. So just watch for that. All right, so what I would do before I tried to actually make the graph is I'm just going to kind of sketch it out down here a little bit. So remember, this is going to be the potential energy in kilojoules, and this is reaction progress, right? So that's like time, or as the reaction is taking place, what's happening, okay? So the first thing I need to think about is, since I know that this is an exo reaction, it usually starts with higher products, and then it's going to end up down here, right? Because that delta H is going to be negative. All right, so then I want to kind of think about how it's going to look. So I'm just going to sort of pre-plug in some numbers, okay, so I can kind of get an idea of how this is going to look. So my reactants are going to be at 1,000 kilojoules, okay? And remember this, EA, the activation energy, is how much higher it has to go, how much energy I have to put in to make it happen. So this right here is going to be 100. So this is going to get me up to 1,100, okay? All right, then it's going to fall back down to the products because those are going to have lower energy. And then this amount here, right, this negative delta H is going to be between the reactants and the products. And I know that's going to be 890, all right? So I'm going to go from 1,000, and then the products are going to be 890 lower than that, so these are going to end up at 110, all right? Okay, so when I make this graph, I'm probably just going to do these by hundreds. 500, right? Which is why you might want to sort of pre-think about it a little bit before you decide, you know, what you want to do. Okay. So my reactants are coming in at 1,000. Okay. My activation energy was only 100. So this is going to be a very slight, peak here up to 1,100. Okay. And then my products, I decided were down here at like 110. So it's going to be sort of like this, okay? Right, so remember, this is my products, this is my reactants, okay? All right, and then I'm going to label everything really nice. Here's my EA, which is 100 kilojoules, okay? And then between the reactants and the products, right, between these two flat lines, is my delta H, which is negative 890 kilojoules. Okay, so I want this graph really nice. I want it quantitative. I want it labeled. Okay, I want it to say reactants, products. I want to see the EA, and I want to see the delta H. Okay, and I want it to be scaled out properly. Okay, all right, so that is what you're going to do for today. All right, remember, it is due technically tonight at 10 p.m. because I want you to work on it on the right day. But it will not be counted as late until tomorrow night at 11:59. At that time, the submission box will lock, and then you cannot submit it after that. Okay, please do this. Please be ready, because on Thursday, I'm going to give you a quiz on this. Details to come, but right, you're going to have to work one out, kind of like I just did, and then you're going to have to explain it. Okay, so I'll give you some more details on how that's going to work as soon as I figure it out. Okay, all right, hope y'all are well.